Right. Today, guys, we are going to talk about right triangle ratios, okay? This is going to get a lot deeper tomorrow, a lot more into it. It's easy, though, but I got to teach you the basics, like always. When we're talking about trigonometry, guys, we're pretty much talking about triangles, hence the tri part, okay? This is really triangle geometry. That's what trigonometry really pretty much means, triangle measures. And it also deals with rotations of angles, which we talked about. So before we talk about how these relationships work, I need to explain to you some more dynamics about these right triangles on the coordinate axis plane. When we have a right triangle and we're dealing with trig, okay, please remember that the initial side of any angle is here, all right? And as the angle goes counterclockwise, that's what forms the angle positively. If I go clockwise, I'm forming a negative angle, okay? So let's remember that first of all. That's going to help you out here. So this particular angle started here, my initial side, and it ends right here at this hypotenuse. That angle is defined as theta. That symbol there, that is called a theta with respect to angle A or theta. Sometimes they'll say find the trigonometric ratios from angle A. Sometimes they'll say from angle theta. A couple other symbols that you should know. This is alpha. It's not capital, it's lowercase, that's alpha. And then sometimes you'll have lambda, which is a little l. Okay? You can have a lot of different Greek letters to represent angles. That's what they like to do in trigonometry. They like to represent with Greek letters. But these are pretty popular, theta, alpha, and lambda. Yes, theta, T-H-E-T-A, theta. Thank you, sir. Okay, so with respect to this angle theta, with respect to this angle A, from this angle that we're dealing with at this particular point, across, whoa, that was bad. Across the theta, guys, that is my opposite side, hence labeled opposite. Now look at what's next to the opposite. It's a y. Why do you think it's a y value? Because it's parallel to the y-axis. Very good. It's a vertical measure. Very good. So that's my opposite. From theta, this guy right next to it, that is the adjacent. In this particular case, the adjacent is the x, because it's the x-axis, or it's going to be parallel to the x-axis. All right? And across from the 90, we already know from the Pythagorean Theorem, is always the hypotenuse, which they call r. And it's called r, guys, because it's a radius. The way an angle works is it rotates. Rotates, right? Well, this particular rotation creates a circle. So upon this rotation, I'd have this massive circle. If this was the center of the circle, we've already talked about conics already, wouldn't this be the radius? Hence, r for radius. That's what we're dealing with. I love that everyone went, oh, that's good. That makes me happy. That's what we're dealing with. That's why I want to really be nice and slow with this, to make sure you guys understand the concept of trigonometry. It's basically finding angle measures as an angle rotates. See what I'm saying? As it rotates. That's what trigonometry is. That's all it is. It's finding angle measures as that angle rotates. And it's rotating, and when it rotates, it makes 360 degrees, which in essence is making a circle. So you can have very large radii, or you can have small radii, and we're going to talk about the unit circle soon, and that's a specific radius. but I want to show you why this is called r. It's the radius of the circle formed by this angle's rotation. Does that make sense, guys? You promise? Okay. Thank you, guys. Awesome. So, I could have it this way, or I could relate it a little bit more algebraically. Sometimes they're going to tell you a certain point P is on a circle. And they want you to find either the theta or the y or the x or the radius. Remember, this P is the point on the circle that is created by the angle that is in motion. Are you guys with me so far? So, it's the same exact setup. Across my theta, the y is the y value. So whatever point this is, that y is right there. The x is the x value. Whatever point that particular value is going through on the circle, that's the x. How do I find the r? Pythagorean Theorem. But this time the hypotenuse is a r. That r is the radius because, again, in this particular example, there's an angle that's traveling. That's a horrible circle, I'm sorry. But it's traveling. It's traveling. It's traveling. At any one point upon its travels, I can create a triangle where I have my y value, my x value, and I solve for r by using the Pythagorean Theorem. Is this concept making sense, at least, so far? Okay. Now let's put it to some use. Let's give you some good stuff here. Let's talk about the trigonometric functions. Finding these values is very easy when you know the trigonometric functions. SOHCAHTOA. You may want to memorize that forever. SOHCAHTOA. SOHCAHTOA. Check it out. So, sine, red. Sine is opposite over hypotenuse. So, opposite over hypotenuse. You with me? The opposite, remember the triangle, you have it right there in front of you guys. The opposite is the y, correct? So that's why I put y. And the hypotenuse is the radius, the r. You with me? It's the same thing, guys. Look at the triangle, it's right on your paper. So, opposite over hypotenuse. Ka, adjacent over hypotenuse. Toa, opposite over adjacent. So sine, opposite over hypotenuse. Cosine, ka, adjacent over hypotenuse. Tangent, toa, opposite over adjacent. SOHCAHTOA. Now, we have already talked about reciprocals before. There are reciprocals for these trigonometric functions. Please be careful. It's a little confusing in a way. Sine goes to cosecant. A lot of people get confused. They're like, why doesn't cosine go to cosecant? Because the guys that invented this didn't want it that way. And that's just the way it goes. So the opposite of sine, or the reciprocal of sine, is cosecant. So if is opposite over hypotenuse, cosecant will be hypotenuse over opposite. Do you guys see that? It's reciprocal. The reciprocal of cosine is secant. So cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And tangent. The reciprocal of tangent is cotangent. And cotangent is opposite over adjacent. So the reciprocal will be adjacent over opposite. These symbols are the shortcut symbols, and that's what you're going to see on calculators. And these are the shortcut symbols of the reciprocals. So everyone with me so far? We're going to put this into action right now. You ready? Yes, guys? Okay. All right. A couple more things. I promise we're going to get to work soon. Now, there are some things that are called identities. Identities are facts in trigonometry that make you quicker at solving things. Remember that we said that sine and cosecant are reciprocals, correct? Okay, well, if I have the value of sine, it's the same thing as saying 1 over the cosecant. Just like if I have a value for so that's this guy. If I have a value for cosecant, that's the same thing as saying it's 1 over the sine value. So for example, if I say the sine of theta equals 8, I want to find the cosecant of theta. Well, isn't that just reciprocal? 1 over 8, guys? That's all I'm doing here. Looks uglier than it really is. You with me? Cosine. Cosine is the same thing as taking 1 and dividing it by the secant. It's reciprocal. To find the secant, it's the same thing as taking 1 divided by the cosine. The tangent is the same thing as 1 divided by the cotangent. And the cotangent is the same as 1 over the tangent. So if I were to tell you the cotangent of theta equals 4/5, find the tangent of theta. 5/4. You reciprocate it. 1 divided by the tangent is just basically the reciprocal. You with me, my man? Everyone with me? Okay. Now, last thing for today. And then we'll start working on this. Cofunctions. A cofunction, okay, remember how we learned complementary angles? Cofunctions are complementary angles. Cofunctions are complementary angles. And the way it works is as such. If I have a sine of a particular theta, sine of whatever degree, that's going to equal the cosine of 90 degrees minus that theta. So if I say, find the cofunction of sine of 40. Well, the sine of 40 is the same thing as saying the cosine of 90 minus 40. So it's the same thing as saying the cosine of 50. If you put into your calculator sine of 40, and then you put cosine of 50, they will be exactly the same answer. They're called cofunction identities. Okay? So cofunctions are literally complementary. So the sine and the cosine are cofunctions, and also the cosine and the sine are cofunctions. The tangent and the cotangent are cofunctions. The cosecant and the secant are cofunctions. The secant and cosecant are cofunctions, and the cotangent and tangent are cofunctions. Does that make sense, guys? Sine and cosine, cofunctions. Tangent, cotangent, cofunctions. Cosecant and secant are cofunctions. Yes, no, maybe kind of, sort of? Okay. Okay, I can see that I'm losing you guys, so let's get right to the work. Find the 6 trigonometric functions of angle theta. Before I can do this, guys, I have to complete this triangle. What law can I use to complete this, or what theorem can I use to complete this? Pythagorean Theorem. So this is going to be 5. It's x squared equals a squared plus b squared. X squared equals 25, so x equals 5. It's a 3, 4, 5 triangle. It is a 3, 4, 5 triangle. In fact, that's something that, you know what, I'm just going to give you a little aside real quick. Real quick aside. There are some things that are called, I wasn't going to teach this, but now that you said it, Pythagorean Triples. These are triangles that are tried and true, that everyone knows these are right triangles, and these relationships exist always. The most common one is a 3, 4, 5 triangle. Anytime that you have a right angle and you have a 3 and a 4 as the legs, the hypotenuse will be 5, period. If you have a right triangle, the hypotenuse is 5 and one of the legs is 3, the others are 4. If you have a hypotenuse of 5 and one of the legs is 4, the others is 3. And any multiples of this will work. For example, they love to give this kind of stuff in the SAT. They'll go 30, 50, and people will be like, oh my God, what do I do? 40. It's a 3, 4, 5 triangle times 10. 3 times 10 is 30, 5 times 10 is 50. Also, this has to be 40. Yes, sir, my brother. No, it does not work with a 5, 6, 7. Now, there are a few other Pythagorean triples. Another very popular one is a 5, 12, and 13. You may want to write this down because it's not in your notes, guys. Maybe you may want to write this down. Yeah, thank you. It's not in your notes. You got that? Yes, sir. 5, 12, 13. Yes, that is a Pythagorean triple. Yes, I promise you. Or any multiples of that. Another very, very popular one, not as popular, but it's an 8, 15, and 17 triangle. And you also have, this one's very rare, but it happens, 7, 24, 25. And you have a 9, 40, and 41. Those are very, very commonly used Pythagorean triples. This will save you oodles of time if you know them. So that's just a little aside there. Okay, yes, sir. No, they'll be similar. No. No. Okay. What my boy is saying is, can you just put any numbers in there and they're going to be triples? No. Because I can do this. I can just make up numbers, 4, 7, 12. It doesn't mean that it's a right triangle.
Like if you find what the gnosis is without knowing it, like it's just 4 and 7, could that not be a priority?
4 and 7, no, those aren't known as the Pythagorean triples. These are tried and true already. These are already there for you because these are very often used. For example, they'll give you something like this. 34 and 30. You can go ahead and go 34 squared minus 30 squared equals b squared. Or you could know that this is a 17, 15, 8 times 2, so that'd be 16. I see what you're saying, and yes, you can find there is an infinite number of Pythagorean triples, guys. My point is, these are popular ones that are going to help you out in trig. Yes, these are whole number ones. Yeah, there's fractional Pythagorean triples as well. These are the 5 most popular ones. Does that make sense? Thank you. So, that's 5. X is 5. Okay, so now, let's do this. I want to find the 6 trigonometric functions from angle theta. So what's my sine of theta? Sine. So, opposite over hypotenuse. 4/5. What's the reciprocal of that? What's the cosecant? 5/4 is the reciprocal. Done. Cosine. What's the cosine of theta? Ka. Adjacent over hypotenuse. What would it be? 3/5. What's its reciprocal? The secant of theta. 5/3. Very good. It's the reciprocal. Tangent of theta. Toa. Opposite over adjacent. What would it be? Opposite over adjacent. 4/3. Guys, the hypotenuse is never adjacent. It's the hypotenuse. What is the cotangent, which is the reciprocal, going to be? 3/4. Bless you. Does that make sense, guys? Pretty simple, right? Okay. This is just baby steps so far. Here I give you all the sides. Find the 6 trigonometric functions from angle theta. Okay, so from here, let's again do this. And guys, little hint. Do not rationalize until the end. Do not rationalize until the end. Rationalize at the end. Trust me. And I'm going to show you why. Okay, guys, what's my sine of theta? So, opposite over hypotenuse. Okay, this is why I'm telling you not to rationalize. If you rationalize this, don't you have to re-rationalize then to find the reciprocal? So make your life easy. Write them all, and at the end rationalize. Please, trust me. Because look, the cosecant now will equal, straight up, square root of 5 over 3. See? You don't have to rationalize 4 times then. See what I'm saying? Sir?
How do you know which side is the adjacent?
Okay, we talked about this already, my man. Look at your first page. From theta, this across one is my opposite. The one next to it is adjacent, and the one across the right angle is always the hypotenuse. Not your bad at all. Thank you for asking. Does that make sense? Does that make sense to everybody, guys? Okay, what's the cosine, guys? Ka. Adjacent over hypotenuse, so 10 over square root of 5. What's the secant? It's reciprocal. Bam, you see, we're saving a lot of time there. You don't have to do it 4 times. And last but not least, what's the tangent of theta, y'all? Opposite over adjacent, 3 over 10. And what is the cotangent? 10 over 3. Oh, yeah. So now, my friends, now let's rationalize. 3 over square root of 5 is going to become 3 square root of 5 over 5. Does everyone know that, or do you need me to show you how I did that? By now you know it, right? And then 10 square root of 5 would be 2 square root of 5. Guys, remember, just in case, you multiply the radical to both top and bottom. 10 square root of 5 over 5 is 2 square root of 5. Does that make sense? Talk to me, guys. I'm here for you. Talk to me, bro. Promise? Okay, may I continue, gentlemen? Okay, Pythagorean triples, that was an extra. Okay. Now, I tell you that the cosine is 2/5. I want you to find the value of the tangent of angle A. If the cosine of A is 2/5, where do I put this 2 and this 5? What does ka stand for? Adjacent or hypotenuse. So I'm going to go 2 over 5. Now, how do I find my missing side? Is that a Pythagorean triple?
Yeah.
No, it is not.
No.
That is not a 3, 4, 5 triangle. 5 squared equals 2 squared plus x squared. 25 equals 4 plus x squared. 21 equals x squared. X equals the square root of 21. Square root of 21. What is the tangent of A? Because that is what I'm looking for.
Opposite over adjacent.
The tangent of A, so in this particular case, the tangent of A would be square root of 21 over 2. Does that make sense, guys? Promise? Some at the bottom? You have it? And I don't have it? How is it that I don't have this? No, I think that, it's on my other disk. Oh my gosh, what an epic fail. Okay, you have it there though, guys. So I'm gonna chug through it. Let's do this. They're asking you guys to write each function or function value in terms of its cofunction. Who's the cofunction for sine? Cosine. So it's going to be the cosine of 90 minus the theta of 30. So that's going to equal the cosine of 60. What's B, guys? Come on, I only got a minute. Guys, what is the question for B?
Cosine of y.
Cosine of x plus y. Thank you. So this is going to be the sine of 90 minus x plus y. So this would equal sine of 90 minus x minus y after you distribute it. Correct?
Yeah.
What is the question for C? Cosecant of 60. Who is the cofunction for cosecant? Secant. No, sine is the reciprocal of cosecant. Secant is the cofunction of secant, and 90 minus 60 is 30 degrees. What is the question for D, please? What is it? Real quick, I know the bell rang. Secant of 30 minus theta. Who is the cofunction to that? So it's going to be the cosecant, check this out, of 90 minus, parentheses, 30 minus theta. So this equals the cosecant, 90 minus 30 minus theta. So this equals cosecant of 60 minus theta. Negative times a negative is a positive. Maybe I should learn how to multiply. Thank you. Awesome, guys. We're done. Homework is valid. May God bless you. Thank you for a great lesson. Tomorrow we continue. Yes. I know there's two more. Can you guys do it on your own? Okay. Thank you, guys. God bless you all. Thank you.